Algebra 1, Day 97. Today we're going to be re-reviewing factoring trinomials. Remember that this is a step-by-step process. You should do this the same every single time. That way you can make sure you always get the right answer, okay? So we will be verifying our work utilizing the calculator today, but let's go ahead and jump into it and start by hand. So, when factoring trinomials in the form of ax squared plus bx plus c, we must find two factors that when they multiply are equal to a times c, but they add together to equal b. Once we find these factors, we group them into two sets and find greatest common factors. We're going to skip this part. And to check if we factored correctly, we can use the calculator. And we can use polyroot or graphing. All right, so let's go ahead and take a look at the very first one. So here I see that a is equal to 1, b is equal to negative 8, and c is equal to positive 12. First thing I'm going to do is I'll go ahead and multiply a times c. So I need two numbers that will multiply together will give me 12, but when added together will give me negative 8. So that tells me these are two negative numbers. So I'll start with the most obvious one, and I see that that does fit that category. So now I'm going to go ahead and I'm going to take my equation and I'm going to rewrite it again, except this time I'm going to split apart my b value. Now I'm going to go ahead and factor out from the first set. I should always have at least an x. Now I'm going to go ahead and factor out from the second set. Now I verify that the insides are exactly the same. They are. I'm going to combine like terms. I am now factored. If this was equal to 0, I could break this apart. And solve for it. These would be my zeros on my graph where they touch the x-axis. Let's look at the second example. All right, first thing I do is I see if there's any greatest common factor. I don't see anything that a, b, and c have in common. So I'm going to multiply a times c. And I'm looking for two numbers that will multiply together will give me 45. However, when they are added together will give me negative 18. So I'm going to start with 1, negative 45. And there are my numbers. Now I'm going to go ahead and I'm going to take those numbers and I'm going to split apart my b value. Now I'm going to go ahead and factor from the first two, factor from the second two, I'm going to verify the insides of my parentheses are the same. I'm going to combine like terms. And if they had asked me to solve it, it would be opposite over coefficient. Opposite over coefficient. All right, next one. So I don't see anything in common, so I'm going to multiply a times c. I need two numbers that will multiply together will give me negative 56, but when added together will give me negative 1. So this tells me there's one positive, one negative, and that the negative is larger. Now this one right here is positive 1, so I'm going to flip it around. And there are my answers. So now I'm going to go ahead, I'm going to take my equation, I'm going to rewrite it and split apart that b value. I'm going to factor out from just the first set. Factor out from just the second set. I'm going to verify the insides of the parentheses are exactly the same. I'm going to combine like terms. And if I was asked to solve, opposite over coefficient, opposite over coefficient. All right, last example. So I see that there's nothing in common to factor out. So I'm going to go ahead and multiply A times C. So I need two numbers that will multiply together will give me negative 24 and add it together will give me negative 10. So I'll go ahead and start negative 1, positive 24. Now this gave me positive 10, so I could flip that around. And there it is. So let's go ahead and break this apart now. Now I'm going to go ahead and factor from just the first one. Factor from just the second one. Now I'm going to verify the insides of my parentheses are exactly the same. I'm going to combine like terms. I am now factored, had they have asked me to solve it, opposite over coefficient. Opposite over coefficient. For our answers, utilizing the calculator. So there are two different ways that we can do this. Actually, more than that, but the two easiest ways are for us to either locate these guys to figure out these numbers using my polyroots, or for us to graph this to verify that it matches, okay? So I'm going to do both. So first thing, let me go ahead and highlight this. Here's my original. Here's my answer. I'm going to graph these to verify that they are the same. So I'm going to head over here to my graph. I'm going to go ahead and name this from the question. So there's my original equation. Let me go ahead and graph what answer I received. Noticing how it overlaps directly onto it, telling me that this is exactly the same. Now, if I wanted to, I could go ahead and do a graph trace. And look at that, my 0 is going to be located at positive 2 and positive 6, just like I predicted here. But if I just wanted to find these numbers, I could have also used a polyroot. So if I go over here and I hit menu, algebra, polynomial tools, find the real roots, we're going to leave it as 2. And I'm going to type in just my values. So my 1, negative 8, positive 12. It's going to fill it out for me. 2 and 6, exactly what I got over here. So let's verify example number 2 now. So x squared minus x minus 56. So I can also go ahead and type it in. I always have to put my comma x. I should get negative 7, positive 8. That's exactly what I got here. But let's verify that this is correct as well by graphing it. So I'm going to head over to my graph. I'm going to put in my equation. It should look like this. Let me go ahead and type in the ones that we factored. And look at that, it lays right on top of it. And let's go ahead and do a graph trace just to verify. Noticing my 0 is located at -7, just like I predicted, and it should be also at +8. And there it is at +8. So good, we got this one correct as well. Let's verify this one. So I'm going to go ahead and I'm going to put in this one, graphing, and I'm going to graph this part down here as well. So I'm going to go ahead and start a new graphing page. I'm going to type in my original equation. I'm going to go ahead and copy it for later. There is my original equation. Let's go ahead and graph on top of that the factors that we found in order to verify that they are exactly the same and correct. And look at that, it lays right on top of it. So that is correct. If I did my graph trace and I look for my 0, it's located here at 0.6, which is equivalent to 3/5 like we predicted, and +3 like we predicted. If I wanted to just get those numbers, I could have done a polyroot. And look at that, I got exactly what I got over here. So we got this one correct as well. Let's take a look at the last one just to verify. So I'm going to go ahead and do my polyroots on this guy as well. And it looks like -1/4 and 3/2. That's exactly what we got here. But let's go ahead and verify this with graphing as well. And I'm going to go ahead and graph the two factors that we found. And look at that, they lay directly on top of there. So let's go ahead and run a graph trace. Let's verify that it should be at -1/4, and it is, and +3/2, and it is. So we got all of these correct. So as you can see, there's lots of different ways to verify your answer. However, you should always make sure and verify your answer no matter what way you choose. So I want you guys to go ahead and get started on your example questions, and I will see you next time.